Oh, all right. This is your Enrico. I'm bringing to you the concepts I learned from machine learning. Without wasting time, let's go through it. Right. So, what is machine learning actually? So, machine learning is a field of study, or it's actually a branch of artificial intelligence that gives computers the ability to learn without being explicitly programmed. For example, as you see in that image, we have an input, can be uh, email, text, can be customer transaction data. When we pass it into a machine learning technique or algorithm, it can be regression, clustering, that is classified into maybe supervised learning or unsupervised learning. What we expect is an output. So therefore, the core idea behind machine learning is we access this data, we learn from it, and make informed decisions on the unseen data. That is what machine learning deals in, where we create models that are able to predict the outcome of unseen data or to work best on unseen data. Right. So there, as I said earlier on, there are two types of machine learning. We have supervised learning. This is where the model learns from labeled data. Then the other is unsupervised learning. Uh, this is the opposite of supervised learning. Here the model learns with unlabeled data. Right. So let's start with supervised learning. So as I said, it learns using labeled data. So therefore, the training data includes the input features and the corresponding correct outputs. For as you see the above image, it shows labeled data where we are seeing the hexagon, triangles, and rectangles. So we label the data. For example, the hexagon shape is an hexagon, a triangle, and a square, actually. Therefore, we pass it through a training algorithm. So in the algorithm, we get our trained model, which is able to give predictions. So the outcome of the predictions is that it will give us those uh, those values. For example, it would have predicted a certain shape. For example, as you're seeing there, it predicted a square and a triangle when it was given test data. Yeah. So there are two types of supervised learning where we have one is classification. Here it predicts discrete categorical values. For example, female or male, or it can be a spam email or not a spam email, like that. Then we have regression. Regression predicts continuous numerical values. For example, house prices, temperature, because they fall into regions. So we have supervised learning algorithms. They include the KNN, decision trees. We have random forests. We have the support vector machine. We have linear stroke logistic regression, and also neural networks. Before we dive into maybe individual algorithms, we can first tackle a bit of the merits and demerits of supervised learning. One of it is, of course, it gives more accurate predictions, especially when this data is labeled. For example, as you saw in the image here, the data was really labeled and it had labels when it passed through the training. it was able to predict for us based on the test data, as you're seeing there. So the other one is it's clear, it's it has a clear objective and measurable performance. Then we go to the disadvantages or stroke demerits. One is that may not generalize well if the training data is biased. For example, if you bias a particular data set, maybe you consider very many females more than men. Therefore, predictions will be biased because the data set was not balanced. So therefore, you have to balance in that we we opt, we opt, we opt for more accurate predictions, and therefore it requires also labeled data, and this is time consuming, whereby you have to, for example, when you have very many data sets, you have to label in that. It helps the model to learn faster based on the label data in order to obtain accuracy. Yes, then after there we have unsupervised learning. As I said later on, it learns on data that is not labeled, or the one that has no target outputs. For example, here, this data is not labeled. You're seeing a triangle, a circle, a square. It's not labeled, and therefore when you pass through unsupervised algorithm, it can be the k-means and so on. It's able, clustering also is there. It is able to group this similar data. As you're seeing, it grouped triangles alone, it grouped squares alone, it grouped also circles alone. That is basically unsupervised learning in brief, as you're seeing in that image. Then we have types of unsupervised learning where I said we have clustering, where we group similar data, for example, customer segments, or even shapes. As you saw in this image, we have shapes, the square, circles, and rectangle and triangles. I mean, then we have dimensional reduction. Actually, here this works best in principal component analysis, where which needs reducing features while preserving the information. Then another type of unsupervised learning is the association rule learning, where you discover relationship. For example, the market basket analysis, where you can analyze very many commodities around the market. We have unsupervised learning algorithms. For example, as I said before, we have the k-means. We have the hierarchical clustering. Then we have the principal component analysis. We shall see, I think, one when we come in front there. So we also have unsupervised learning advantages and disadvantages. So now here, the one of the merit is it saves time. You know why? This is because there's no need to label the data, and also it can discover hidden patterns humans might miss. This is because since models learn from experience out of doing repetitive tasks for many times, so they learn a lot from this experience and become more super, even more than human beings. So the demerits is that results can be harder sometimes to interpret and validate them. Then also they are less accurate for the prediction tasks. All right, then actually we have the machine learning pipeline from the problem definition to the monitoring and maintenance. Let's start with the problem definition. So in problem definition, you have to clearly state what the model should predict. Then in data collection, you gather the relevant data from data sets, can be databases, APIs, and so on. Then you do what we call the data pre-processing. Sorry, these processing must not be there. So then we do what we call data pre-processing. Here in data pre-processing, we clean data by handling the missing values, dealing with duplicate values. In that, we also do reducing noise and removing inconsistencies. Then in next is we have exploratory data analysis. Now, this is where you analyze the data to understand the patterns, the trends, and the relationships we have in the data. Then we do what we call feature engineering. Feature engineering, you select and transform the variables to improve the model performance. For example, you can do feature normalization here in that a feature does not dominate than the other. For example, age can be between 0 up to maybe 150 because the lifespan of nowadays, people die at 70s, they don't reach even 120. Then we have the train test split. This is where you split the data. We divide the data into the training data and the testing set. Then we do what we call model selection. You select the model, the appropriate model, you select the appropriate machine learning algorithm based on the data you have. Then we have what we call model training. This is now where you train the model in order to obtain a model that predicts or gives results. Then we do what we call model evaluation. In model evaluation, we can use metrics. For example, we have the accuracy score, we have the root mean square value in order to see that our model performs well. Then we have hyperparameter tuning. In hyperparameter tuning, this is where we optimize our model parameters to improve accuracy. We also have we deploy. After all that is done, of course, we have to avail the model for the real world use. Then we monitor and maintain the model while in use. We can dive into the KNN concept. This is an algorithm of supervised learning actually, whereby it has the parametric and non-parametric models. So in parametric models, here you know the model exactly, where you know the model exactly. For example, then we have the non-parametric. So this one already tells you what the regression looks like. The overview of the KNN, it's a non-parametric algorithm. Then also, when we don't have prior knowledge, it becomes our first choice, and besides that, consequently, it's used for both regression and classification. All right. Then it has actually 3 main steps. This is main step. Some say it's 5, but no, it's actually through the course I learned. It said it had 3 main steps. That is 1, you calculate the distance between all the training data and the test points. Then also you find the nearest k neighbors by sorting the pairwise distances. And lastly, you classify the point based on the majority vote. We have the distance metrics and hyperparameter tuning, the KNN, whereby here we use distance metrics. For example, we have a Euclidean distance. Here we do that if we are measuring dimensions with similar properties. Then we have Manhattan distance if the dimensions are dissimilar. Then we also have what we call feature normalization. If this is what I mentioned earlier on, as if these features are not on the same scale. For example, age. If you don't want age, a particular number to over-dominate in a data set, you have to do what we call normalization, whereby you can say age ranges from maybe 0 up to 150, like that, in to prevent a particular figure from dominating. Then we have what we call hyperparameter tuning. Here we do not tune hyperparameters using the test data, because this can lead to data leakage, whereby a model and therefore whereby a model would cheat by seeing already by seeing. Okay, let me give it in a layman's language. In that, for example, this when you use test data, actually, it's like a student seeing exam questions before doing an exam, meaning he or she has cheated. So therefore, it leads to overfitting. So we do hyperparameter tuning through cross validation, where we split data into the key groups, then you rotate the test set to use all the data. So this prevents data leakage. Then we have applications, advantages and constraints of the KNN. In the applications, we have the text mining, we have agriculture, finance, and cargo competitions. We have advantages. It's easy to explain. They don't have assumptions on the distributions. They handle multi-classes. Then constraints efficiently declines as the dataset grows. Cannot handle missing values, and so on. Then we have another algorithm which is called decision trees. These decision trees, actually, we have several of them. We have several algorithms under decision trees. For example, we have the Gini impurity, where we can measure the frequency of the mislabeling, but its values, it lies in the range of 0 to 0.5. Then the entropy, it measures the disorder. Also, its value ranges from 0 to 1. So here it's more complex, actually, because it uses logs. Then we have the information gain. It's biased for attributes with many outcomes. So also, to solve the problem of overfitting under decision trees algorithms, we do what we call pre-pruning and post-pruning. So pre-pruning is where we stop the growth earlier, whereby we can specify the maximum depth, can be the third level, depending. Then the post-pruning, it's we grow a large tree first, then of course we prune back. It's cost complex, actually. Then we have advantages and disadvantages of decision trees. One of the advantages, it's easy to interpret. It's non-parametric, yes. Then it also captures linear patterns and so on. Then disadvantages, it's sensitive to noisy data overfitting. Then also, it's biased with imbalanced data. We have another learning called ensemble learning. This is where we find bootstrap and bugging. So the overview of assembling is where we combine weak models into a supermodel. So therefore, in bootstrap, this is where a challenge of estimating population information from a sample is actually denoted an address. Then in bagging, we create different models using the bootstrap training and average predictions. This helps us to improve the accuracy of our model with respect to interpretability. And then for the random forest and boosting, the random forest and boosting is a collection of the correlated decision trees. So the process can be we randomly pick features from each split of sample examples. It has also advantages. For example, it's robust to outliers. It detects outliers faster, meaning it lowers overfitting risks. Then it has disadvantages. For example, it's biased with categorical values actually because of slow training. We have boosting versus bagging. We all know that boosting, this is where a sequential tree growing is weighted samples. Then the other one, it's parallel tree growing, but with also samples. So thank you for listening.